Hello, everybody, and welcome to the Science and Technology Explained. The aim of the channel is to explain science in understandable fashion and layman terms. The focus will be on data and reasoning and logic, and rather than blurting out opinions. In my background, I'm a chemical engineer, and I've been that for over 25 years. I'm using data from open sources, for example, from Our World in Data, which is an excellent site. And in this episode, we will looking at the energy in our world, the energy use, the fossil fuels, the impact of the world, and next steps for our energy on the planet. So let's take a look. Starting off here, we can see the graph is showing us the global energy consumption by source. This is from the year 2000 up until 2024. And first of all, let's look at the global energy consumption currently. It's a whopping 180,000 terawatt hours. But first of all, what and how much is a terawatt hour? So a terawatt hour, if we start how watt hours mean, for example, if we have a standard microwave, it has a power of around 1000 watts. If this is operated for 1 hour, we get 1000 watt hours. That's the same as 1 kilowatt hours. So if we then take 1 billion microwave ovens, that's 1000 million microwave ovens running for an hour, we have consumed 1 terawatt hour. Another example is if you have a 60 watt light bulb, the old kind, and if that one of those was running on continuously for 2 million years, that's also 1 terawatt hour. And then 250,000 average households today are using around 1 terawatt hour per year. On the production side, if we look at the world's largest coal power plant in China, the Tetuoco plant, this has a capacity, a power of 6.7 gigawatt. If it operates for a whole year, we're getting 58 terawatt hours per year. Looking at the energy again evolution from 2000 to 2024, we can see an almost continuous increase. There are a few blips in the world energy consumption and demand, and that's typically some crisis. Here we have the 2008 financial crisis, and here we have the 2020 COVID crisis. And also, if we look at the graph, we can see that from 2000 until 2024, there is a vast increase in the energy demanded by the world, 50% more, and what we also can see is that more than 3/4 of the energy consumed in the world is coming from fossil fuels, coal, oil, and natural gas. And we can see also compared to the 2000, we can see a steady increase for coal, oil, and natural gas. If we look at the nuclear and hydropower, they have been quite stable in the period. Hydropower is not very easy to expand. Nuclear power we don't have the very much political will to expand nuclear power. And we see from the around 2010s, we can see the start of increasing of renewable sources like wind, solar, other renewables, and modern biofuels. If we take a step back even beyond before 2000 and we go all the way back to the 1800s, here we can see even more profound growth in the energy consumption of the world, starting with only traditional biomass like wood and stoves and things like that. And here we can see the incredible growth in energy consumption. And here we can see the phasing in and introduction of fossil fuels, starting with coal, followed by oil, and then natural gas. But what does the world use all this energy for, and how has it impacted our lives? In short, we are becoming more and more people on the planet. Here you can see the global population from 1800 to 2023, and we see going from 1 billion up until 8 billion people around now, and we can see that the trend is eerily looking at the same as the energy curve, and the big growth as we are using energy to improve our life conditions and the more people on the planet. So, for example, introducing vast amounts of energy and fossil fuel-based energy has revolutionized agriculture in the early days of human history. Everything was manual labor or animals, and the more animals and human labor was needed for the agriculture, the more food was actually needed, and a couple of rains at the wrong season or misgrowth would lead to big famines. And in the 1800s, the life expectancy was around 30 to 40 years. In modern times, for example, we are using fertilizers to really increase the output of the how much crops are yielded by agriculture. There is a machinery using energy to do the work of multiple humans. So with few human resources, we can produce a stable food supply for a lot of people, and this of course has been accelerating the population growth. Apart from more people, we have also become richer with time. This is the global GDP evolution from the 1800s up until our days, and we can see a massive increase, almost the same trend, and like the energy and the population growth. This is even larger growth than population and energy-wise. And this is much higher. This means also much higher living standards and quality of life. And as I said, the life expectancy in the 1800s, where we have the image of New York here, was around 30 to 40 years. Today, New York looks completely different and a lot has changed. I would argue that an average person in the industrialized world today lives a much more luxurious life than the kings of old time. And the kings of all time, if they could see what we have access to today, I think they would be really jealous. We have abundant food quantity, high food quality. We have variation of food that they couldn't dream of. We can get foodstuff from all across the planet. We have medicine, we have high comfort, we have heated homes, we can travel and unparalleled mobility, for example, going on vacation, information, entertainment, and much, much more. And although not for every person in the world has access to the same things, I think we are better off today than we were at all times. So now let's take a look at what the main uses of the fossil fuels are, starting with the earliest one to be adopted, coal. And the planet is using 22 million tons of coal per day. The main uses for coal are for electricity production. 70% of the coal is used for electricity production, like the largest one we saw in China. 20% though also goes to steel, cement, and other industry. Steel and cement really important for the buildings, and for the picture of New York, we saw in modern day a lot of steel and concrete and cement used there. If we continue to oil, oil has quite a different use than coal. The world is really has a lot of thirst for oil, 100 million barrels a day. This is a very high number, and one barrel is 160 liters or 42 gallons. It's almost unimaginable amounts of oil consumed every day. Oil is not really used to make electricity. 70% of the oil in the world is used for transportation fuels, from aviation, land transport like cars and passenger cars and heavy road traffic, and of course marine that really transports a lot of the goods and for example foodstuffs around the world. 20% of it goes for petrochemicals, that's plastics, rubber, etc. And this is also, if you take a look around your house, everything, there is a lot of plastic and there is a lot of access to things that previously would have been very expensive, or not many people would have had a lot of items. Finally, looking at natural gas, the world is also using vast amounts of natural gas, 11 billion cubic meters per day. This is also very hard to imagine. And the main uses for natural gas is more diverse. 40% of it goes for electricity production. 20% is used for residential and commercial, for example, heating and cooking with natural gas, or heating our homes with natural gas. But 30% has also very important use in the industry to produce, for example, ammonia. This is really a big chemical that's used for fertilizer, as we said. So fossil fuels make fertilizer that become food at the end for our to put on our table, and methanol and other chemicals that really are needed for the variety of items we are using. But of course, using all these fossil fuels has a flip side, and quite a bad flip side. First of all, we have, of course, pollution. There is, for example, from road transport, we get smog and bad quality of air. other pollution. We also have, of course, high amount of CO2 emissions. This graph shows us from the 1800 up until our days the CO2 in the atmosphere, and we see it's almost the same graph as we saw from energy use, population growth, and GDP. And this can lead to various degrees of climate change. The exact amount of climate change, of course, is not very easy to predict exactly. It depends on models, etc. But we can see the clear CO2 increase. Also, fossil fuels are not infinite source on the planet. It's a very finite source. It's not really well spread out on the planet, and this also leads to a lot of geopolitical tensions. Everybody probably recognizes this geographic section, the Strait of Hormuz right now, a big issue with 20% of the oil flowing from the Middle East to, for example, Asian markets here. So a lot of flip sides from fossil fuels. So what can we do to sustain the world's population, to have a high living standard, but to avoid the flip sides of fossil fuels? I don't think it's realistic. I think it's very unrealistic that we should reduce our energy consumption to very early, let's say 1900 levels. I don't think it's really feasible to do. So I think the thing we need to do is to try to, let's say, with energy efficiency, and now maybe world population is starting not to grow as much, to try to moderate the energy increase demand, so the curve on the demand flattens out a bit, and then start replacing in parallel fossil with non-fossil fuel sources. And the most feasible areas currently, in my opinion, is for, first of all, electricity production. This is already ongoing, but we can start replacing fossil fuels in the electricity production, like coal and gas, with more sun, wind, hydropower. But in this mix, we would also need, for example, nuclear, because nuclear is a not intermittent and not weather dependent electricity source. As I said, the electricity production is starting to become more green. For example, if we look at the European Union, in 2025, almost 50% of the electricity was produced from renewable sources, 23% from nuclear, and only 30% from fossil fuels. If we look at the US, 24% renewables. If we look at China, 34% renewables, a little bit less nuclear here. And then the next step from electricity, as the electricity production becomes more and more green, the next easy step, let's say more feasible step, is to also electrify land transport with electric cars, or electric trucks are a bit more difficult. But this is also ongoing. So we have a lot of electric cars being introduced. For example, in Denmark, 55% of the new cars are electric cars. In China, it's already 50% and growing. In the European Union as a whole, it's only 20%, and in US, it's 10% the share of electric cars in new builds. So the more electrification on land, the more green the electricity production, the less we will use fossil fuels to produce electricity, and we will use less fossil fuels for our main transportation. And finally, for buildings, replacing, for example, gas for heating and cooking, and making things more electrically driven with heat pumps or district heating could be some good alternatives. So this concludes the video, and I hope it gave you some valuable insights into the complex world of energy and fossil fuels. Please give us a like and subscribe to the channel of Science, Technology and History Explained, and I will be really glad to hear your comments about this video or next coming videos. And stay tuned for more follow topics, for example, what is power to X, the difference between power and energy, how is energy really produced, and electricity from coal and thermal sources, what is chemistry, and much more. So with these words, we are signing out. Stay safe out there, and bye-bye.